My name is Allen Sandwell. I'm a master's student here at the University of Calgary, and I work for Dr. Simon Park. He's the mechanical professor here. In my project that I'm focusing my studies on is sensing. So what I'm trying to sense here, or take readings of, is forces. So a force can be something as simple as me pushing on this table. I'm exerting a force onto it. Or pulling up this piece of equipment or something like that. Basically being able to tell how much I'm pulling up and for how long and for anything that I'd want to know. Unfortunately, because forces can be fairly difficult to read, we only have a few different ways of doing it. And it gets very tough to do it when those forces are very small. For instance, if I just very carefully push on the table. There's only a few instruments that I can use at this point that will be able to pick that up to an accurate level that I'd like. And unfortunately, as we get into smaller things, so one of the big things to talk about, and you probably hear on any sort of school, is nanotechnology. So things that are very, very, very small. When things are very, very, very small, they generate very, very, very small forces. So if we want to be able to accurately measure those forces, which can be extremely difficult but also very important in our studies, we need to develop methods in order to do that. Typically, forces are measured using things called strain gauges. So essentially, when we look at anything in the world, we can almost decompose it into what we call springs. So little spring elements you might be familiar with. So basically, anytime I apply a force on something, no matter how small, I'm going to achieve some sort of displacement or movement of that piece, a deformation, if you will. So again, this is very, very on a large scale, but essentially anything I touch, any right here, behaves exactly like the spring on a much smaller scale. So me pushing down here, whoops, if I let that fall away, is the same as me pushing down on this table, but much, much smaller, something that I can't even detect. One thing I can do though, is I can use lasers. So lasers are something very, very cool. If you wanted a little bit of a lesson, it's light amplification by selective emission of radiation. And basically what I can do with lasers is it's composed of photons, which are the elementary particles that compose light. So if I turn on this light right here, as you can see, I have a little reflective target here, and I have a little detector here that's made out of cardboard and paper. What this would actually be is what's called a photodiode. So a photodiode is basically something that creates electricity every time I shine a light on it. Basically, if a photon comes from my laser beam here and is emitted or absorbed onto the sheet, basically it creates an electrical current that I can then detect with some sort of electronic machinery. So what I can do here is, just like that spring concept we were talking about, if I have something I want to measure the force on here and I push it, my light source moves. And if I have detectors in each of these quadrants, I can then detect where that position of that light is changed to. And by corroborating that with the spring, or the stiffness of that particular piece of equipment, I can tell how much force I in fact put on it to move it.